Okay, in this video, we're going to discuss section 6-2, dealing with addition, subtraction, and estimation with rational numbers. And in this video, we'll talk about how to add rational numbers with like and unlike denominators, also convert rational numbers to mixed numbers and vice versa. Also, we'll subtract rational numbers with like and unlike denominators. Also, we'll recognize properties of addition and subtraction of rational numbers. Also, recognize addition properties of equality and estimate rational numbers. Okay, so let's start off by stating that addition and subtraction of rational numbers are very much like addition and subtraction of whole numbers and integers. And here we illustrate that by adding two rational numbers with like denominators. And in this case here, let's say we got 2/5 and 1/5. And we're going to use the area model and the number line model. So here's what the area model looks like. Here I got a circle and it's sectioned into 5 equal parts. And 2 of those parts are shaded. That represents 2/5. And then I have another circle sectioned evenly into 5 equal parts. And one of those parts is shaded out of 5, so it'll be 1/5. Now, if I combine the two, 2/5 and 1/5, that means I have 3 shaded pieces of the circle out of the total of 5 pieces. So that means that's going to be 3/5. So 2/5 and 1/5 adds up to 3/5. Now, if we use the number line model, as I have here, 2/5 plus 1/5, that's equal to 3/5, as you can see. On a number line model, to illustrate that, 2/5, you'll have a number line from 0 to 1, and it's divided evenly into 5 parts. So 2/5 would be from 0 up to 2/5. Then if I add another 1/5 to the 2/5, I will end at 3/5. So 2/5 plus 1/5 does equal to 3/5. Okay. All right, next we'll look at the definition of addition of rational numbers with like denominators. Let's say if A over B and C over B are rational numbers, then in this case here, your denominators are the same, A over B plus C over B. In this case, it'll just be this. We add the numerators, A plus C, and keep the same denominator. Okay. Now let's look at 2 rational numbers with unlike denominators. In this case here, we want to do 2/5 plus 1/4. I mean 2/3 plus 1/4. So here I have a circle divided into 3 equal sections. 2 of those sections are shaded. That's 2/3. And then 1/4, here I have a circle divided into 4 equal parts. One of those parts is shaded, so that's 1/4. Now, when I combine the 2 together, what we're going to have to do here is come up with equivalent fractions for 2/3 and 1/4. For 2/3, the equivalent fraction is 8 over 12. And for 1/4, the equivalent fraction there will be 3 over 12. In other words, we have to find what they call a least common denominator, or in this case, divide your denominators. Multiply your denominators like 3 and 4. Multiply those 2, you'll get 12. So 8 12s and 3 12s will give you 11 12s. Okay, which is represented here. Okay, 12 equal parts, 11 of those 12 parts are shaded. So here is the definition for addition of rational numbers with unlike denominators. And in this case, if I have A over B and C over, and this should be C over D, not C over B. Okay, so I need to correct that. A over B and C over D are rational numbers. Then A over B plus C over D will be this. Here they multiply the denominators here, B and D, to get BD in the denominator. Now for the AD plus CB, they did a little bit of cross multiplication. A times D will be AD, and then B times C will be CB, and it's addition. So that idea can be used in these examples here that I'm going to show you right now. And in this case, starting with part A, we got 2/15 plus 4 over 21. 2/15 plus 4 over 21. In this case here, if I want to, I can multiply 15 times 21, which are my two denominators. I'll multiply those. And then to get my numerators, I'll just do a little cross multiplication with the 2 and the 21. So that's 2 times 21 plus 15 times 4, or 4 times 15. Does not matter which one goes first. So in this case, if I do 2 times 21, that's going to be 42 plus 4 times 15, that's 60, divided by 15 times 21. This will end up being 315. Now I can add the 42 and the 60 together. I would get 102 over 315. Now, in some cases, you're going to have to write that fraction in simplest form, meaning you're going to have to do a little reducing here. So I have to find the largest number that would go into 102 and 315. And in this case, it's going to be 3. So I have to divide the numerator and the denominator by 3. So 102 divided by 3 will be 34 over 315 divided by 3. That'd be 105. So in simplest form, my final answer there will be 34 over 105. So that's part A. Now part B, we got 2 over -3 plus 1/5. 2 over -3 plus 1/5. Here's what I'm going to do. Multiply my denominators here, -3 and 5. Then I'm going to do a little cross multiplying here with 2 times 5. I'll write that up here. And this is going to be plus this cross product, -3 times 1. And then we simplify here. 2 times 5 will be 10. Plus -3 times 1 will be -3. All over -3 times 5, that'll be -15. And then 10 plus -3 will be 7. That's going to be over -15. So we'll end up with 7 over -15, or we can write that as -7 over 15. The negative in front and then 7/15 behind it. So that's part B. Now part C. Here we got 3/4 plus 1/5 in parentheses plus 1/6. Okay, in this case, that 3/4 plus 1/5, you know what I'm going to do here? I'm going to go ahead and get a least common denominator for 4 and 5, which will have to be 20. Okay. So the LCD of 4 and 5, that's going to be the smallest multiple for 4 and 5. The smallest multiple that's divisible by 4 and by 5. That would have to be 20. And then, of course, or if you want to, you can do the cross products if you like. 4 times 5, that's 20. Then 3 times 5, that's 15. Plus 4 times 1, that will be 4. And then plus 1, 6. So 15 plus 4 would be 19 over 20 plus 1, 6. Excuse me. And I'll do the same thing here. For the 20 and the 6, if I multiply 20 times 6, that would be 120. And then cross product with the 19 and the 6. So if I do 19 times 6, I would get 114 plus 20 times 1 would be 20. Add 114 to 20, you'll get 134 over 120. And I will have to find the largest number that can go into 134 and 120. It would have to be 2. So if I divide the numerator by 2 and the denominator by 2, let's see, 2 goes into 134 67 times, and 2 goes into 120 60 times. And I will leave that as an improper fraction. So here, 67 over 60 would be the answer to part C. For 3/4 plus 1/5 plus 1/6. And then part D. Part D is this, 3 over X plus 4 over Y. Okay. Now for this one, I can go ahead and multiply X times Y, which would just be XY. And then cross multiply 3 times Y will be 3Y plus X times a 4 would be 4X. And in this case, that would be as far as I can go with that problem. So it'd be 3Y plus 4X all divided by XY. And part E. Here I got 2 over A squared plus 3 over AB squared. 2 over A squared B plus 3 over AB squared. Now, in this case here, I'm going to need to find something called the LCD or LCM, doesn't matter. Okay, the least common denominator would be, with these variables, we have to take each variable to the highest power. So the A, I have to use the highest power for A, that's going to be A squared. For the B, I need to use the highest exponent for the B, and that's going to be B squared. So A squared, B squared would be the LCD for those two fractions. Now we need to write an equivalent fraction with our least common denominator. Let's take a look at 2 over A squared B. I do have A squared. I do have a B, but for that to be B squared, I need to multiply the numerator and the denominator by B, because I want that denominator to be A squared B squared. And then plus, for the 3 over AB squared, notice that I need another A for that to be A squared. I've already got the B squared, but I need another A for that denominator to be A squared B squared. So I need to multiply the numerator and the denominator by A. So in this case here, if I multiply 2 times B, that'll be 2B over A squared B squared plus 3 times a will be 3a. That will be over a squared, b squared. And then we go ahead and write all of this under one single denominator. Since the denominators are the same, I can write that as 2b plus 3a, all divided by a squared, b squared. Okay. All right. Let's look at some more of these addition problems here with rational numbers. Like part A, -1/7 plus 2/3. -1/7 plus 2/3. In this case, I can multiply 7 times 3 and get 21. That would be the least common denominator, by the way. And then to get my numerators, I'll just do cross multiplication here. Like the -1 times 3, that'd be -3. And then plus 7 times 2 will be 14. And then -3 plus 14 will be 11. And that will be over 21. So 11 over 21, excuse me, would be the answer to -1/7 plus 2/3. All right, now part B. We got 7/6x plus -5/3y. Now what I'm going to need here is a least common denominator for 6x and 3y. Well, I need the largest number that's divisible by 6 and by 3. And in this case, it'll have to be 6, because 6 is divisible by itself and 6 is divisible by 3. And also I need, for the variables, the x and the y. So 6xy is the LCD for those two denominators. Now we need to write equivalent fractions for this. So for the 7/6x, well, I got the 6, I got the x, I need a y. So I need to multiply the numerator and the denominator by y. And then plus -5/3y. Well, I got the y. I need an x. And I also need to know what number times 3 would give me this 6. It will have to be 2. So 2x is what I need to multiply in the numerator and the denominator. So if I simplify this, 7 times y will be 7y over 6x times y, that's 6xy, plus, let's see, -5 times 2x will be -10x over 3y times 2y. Well, 3 times 2 is 6. X times y will be xy. Now what I'm going to do here is put all this under one denominator, so it'll be 7y. And I can write that as -10x, because plus or negative is the same as subtraction. So 7y minus 10x will be over 6xy. And that will be the final answer. Okay. All right, part C, we got -7 over 3x squared y squared plus 5 over 3xy squared plus 2 over x squared y. So here I need an LCD. Well, for the 3, there's no problem. It will be 3. Now for the x, I need to use the highest exponent for the x, which is in this case going to be x squared. And for the y, I need to use the highest exponent, y squared. So my LCD will be 3x squared, y squared. Now let's write our equivalent fractions here. So for -7 over 3x squared, y squared, that is the LCD. I've already got the 3, I got the x squared and the y squared, so I don't need to multiply the numerator and the denominator by anything because I've already got that LCD. Now for the 5 over 3xy squared, I got the 3 and I got the y squared. I'm missing an x. I need this x to be x squared. So I need to multiply a numerator and denominator by x. And then plus the 2 over x squared y. Well, I'm missing a 3, so I need to multiply the numerator and the denominator by 3. I've got x squared. I'm missing a y. I need to make this y squared, so I need to multiply the numerator and the denominator by y. All right, so now let's simplify this. This will be -7 over 3x squared y squared plus, for this one, 5 times x is 5x over 3x squared y squared plus 2 times 3y is 6y over 3x squared y squared. So now my denominators are the same. I can write all our numerators on top, all over a single denominator. So this is -7 plus 5x plus 6y, all that's divided by 3x squared y squared. And finally, part D, we got -3 and 1/3 plus 1 2/9. Okay. Now we're going to talk about these types of numbers shortly. Now, in this case here, we're going to find the least common denominator for 3 and 9. For 3 and for 9. And in this case, it will be 3. No, I'm sorry, it'll be 9. So the LCD is 9. Now for the 3 and 1/3, I'm gonna bring the -3 over. That 1/3, if I want that denominator to be a 9, I need to multiply both the numerator and the denominator by 3. And then plus, well, I've got the 9 in the denominator for the 1 2/9, so I can go ahead and bring that over. So if I write down my -3, 1/3 times 3 over 3 will be 3/9 plus 1 2/9. Now in this case here, we're going to use the rule for adding integers with different signs. Okay, and it's this: if we're adding 2 integers with different signs, we subtract and take the sign of the larger absolute value. So in this case here, if I subtract 1 from 3, that will be 2, and I subtract by fractions, 2/9 from 3/9 will be 1/9, and give the sign the larger absolute value. It's negative, so that means my final answer will be -2 and 1/9. Okay. All right, so that's how we add fractions. Okay, now now part D, the one that I just did, is what we call mixed numbers. Those are numbers that are made up of an integer and a fractional part of an integer. A mixed number is a rational number, and therefore it can always be written in the form A over B. Okay, so like in this example here, Let's say I want to change each of the following mixed numbers in the form of A over B, where A and B are integers. So for part A, we got 4 1/3. And the way we do that is this. The denominator is 3, so we bring that over. But to get our numerator, we just take the denominator, multiply it by the whole number. That's going to be 3 times the 4, and then we add the numerator. Denominator times whole number plus the numerator. So it'll be 3 times 4, which is 12. 12 plus 1 would be 13. And that denominator is 3, so that 13 will be over 3. So 4 1/3 as an improper fraction will be 13 over 3. And then part B, we got -3 2/5. -3 2/5. Now in this case, we're going to bring over the negative, and then we're going to write 3 2/5 as an improper fraction by taking the denominator. And by the way, this will be over that denominator of 5. We take the denominator, multiply by the numerator. So it'd be 5 times 3. Well, denominator times the whole number plus the numerator. 5 times 3 plus 2. Bring this negative over. 5 times 3 is 15. Plus 2 over 5. And 15 plus 2 will be 17. So it'd be -17 over 5. -17/5. All right, here's some more examples of just this. All right, let's say we had this. Change the following mixed number to a fraction in the form of A over B, where A and B are integers. Like in part A, 2 5/11. And I'm going to change that to a mixed number. So 2 5/11, just like I did here in the previous example. We take our denominator of 11, multiply it by the whole number of 2, and then add the numerator. So 11 times 2 will be 22. And then 22 plus 5 would be 27. And we write that over 11. So 2 5/11 as a fraction in the form of A over B will be 27 over 11. And then part B, we got -7 1/4. And we want to write that in a fraction of the form A over B. Here I'm going to bring the negative sign over, and then I'm going to do the denominator of 4 times the whole number, which is 7, plus 1, all over 4. Bring this negative down. We'll do 4 times 7, that's 28. 28 plus 1 would be 29. That's going to be over 4. So -7 1/4 will be, as a fraction in the form of A over B, -29/4. Okay. All right, so here we converted a mixed number into a fraction in the form of A over B. Let's say we have an improper fraction like this one, and we want to convert that to a mixed number. So here I want to change 29/5 to a mixed number. Well, here's where we do the long division. So that means I need to divide 5 into 29. Well, 5 goes into 29 5 times. And then 5 times 5 will be 25. Subtract 25 from 29, you'll get 4. Okay, so 29/5 would be the 5, which is my quotient. The remainder will be the numerator, my divisor will be the denominator. So it'll be 5 4/5 for 29/5. All right, here's some more examples of this. 50 divided by 50 over 3 and negative 357 over 100. We want to change those to mixed numbers. So let's start with 50 over 3. So here I'm going to divide 3 into 50. Well, 3 goes into 5 one time. So 1 times 3 will be 3. That give you 2 left over, bring down the 0. 3 goes into 26 times. 3 times 6 is 18. Subtract 18 from 20. You'll get 2 left over. So 50 over 3 would be this. My quotient is 16. The remainder is the numerator. That'll be 2. And then that divisor is 3. So 16 2/3 is the mixed number for 50 over 3. And then part B, negative 357 over 100. And we know it's going to be negative. So here, I'm going to divide 100 into 357. Well, 100 into 357 will go 3 times. 3 times 100 is 300. 300 from 357 will leave us 57. And I cannot divide 100 into 57. So this 3 up here is my whole number. The remainder of 57, that's going to be the numerator. And 100 would be my denominator. So negative 357 over 100 would be negative 3 and 57 100ths. Okay. All right. Let's look at some properties of addition for rational numbers. All right, rational numbers have the following properties for addition: closure, commutative, associative, additive, identity, and additive inverse. Now, if you remember back in Math for Teachers 1, we did talk about those properties for addition. They're also true for rational numbers. Now, to emphasize the additive inverse property of rational numbers, we state it explicitly as follows. Okay, so here's the additive inverse property. For any rational number, A over B, there exists a unique rational number, negative A over B, called the additive inverse of A over B, such that if I have A over B plus its additive inverse, which is negative A over B, that's going to be equal to 0, which is also the same as saying negative A over B plus A over B. They're both additive inverses of each other. So in this example, let's say I want to find, if I can get to it. Here we go. Let's say I want to find the additive inverse of each of the following. You'll want to find the additive inverse of each of the following, like 3/5. It's a positive 3/5, so the opposite of 3/5 would just be negative 3/5. That's all there is to it. And in part B, negative 5/11. The additive inverse of that would be just simply 5/11. And then for 4.5, its additive inverse would be just simply negative 4 1/2. Now, if you wanted to, you can write that as a improper fraction of negative 9/2. Denominator times the whole number plus the numerator. Okay. All right, properties of the additive inverse for rational numbers are analogous to those of the additive inverse for integers. So with integers, the opposite of a negative a would be a. And here the opposite of the sum of a and b, we just take the opposite of each of those numbers. Negative a plus negative b. The same holds true for rational numbers here. The opposite of negative a over b will be just positive a over b. And then the opposite of, and that should be a over b plus c over d. I don't know where that came from. So let me wipe that out. That should be the opposite of a over b plus c over d. That would be just simply negative a over b plus negative c over d. Distribute the negative over the a over b and the c over d. All right. Now for the addition property of equality is this: if a over b and c over d are any rational numbers such that a over b is equal to c over d, and if e over f is any rational number, then I can add e over f to both sides of this equation. And still, the equality will be true. Okay. And that's the same as just for whole numbers. A is equal to c, and let's say b is some number, I can add b to both sides. The same thing here, I can add e over f to the left side and e over f to the right side. All right, next we'll look at subtraction of rational numbers. All right, let's look at the definition of subtraction of rational numbers in terms of addition. If a over b and c over d are any rational numbers, then a over b minus c over d is the unique rational number e over f, such that a over b minus c over d is equal to e over f. And as with integers, we can see that subtraction of rational numbers can be performed by adding the additive inverses or adding the opposite. So let's say if a over b and c over d are any rational numbers, then a over b minus c over d is the same as a over b plus the opposite of c over d will be negative c over d. Okay. So if you were subtracting, that's going to be the same as adding the additive inverse or adding the opposite. Okay. And sometimes this sometimes given as a definition of subtracting integers. Similar to adding integers here, if we have a over b minus c over d, pretty much we can multiply the denominators, b and d. But we want to be careful here when we do cross multiplication. You want to do this cross product first, going in this direction from the upper left to the lower right, and then minus this cross product from the lower left to the upper right. Okay. Because here subtraction is not commutative. So you want to do this cross product first, and then minus that cross product first. Or, of course, you can always find the LCD of your two denominators and then write your equivalent fractions from there as well. So here's a couple of examples of that. Let's say we got 5/8 minus 1/4. 5/8 minus 1/4. And here I want an LCD of 4 and 8. That's going to be the smallest multiple that's divisible by 8 and by 4. And in this case, it has to be 8. Because 8 is divisible by itself and 8 is divisible by 4. Now let's write our equivalent fractions. For 5/8, we already got the denominator of 8. But for the 1/4, if I want that 4 to be at 8, I need to multiply the numerator and the denominator by 2. So I'm going to bring over the 5/8 minus 1/4 times 2 over 2. 1 times 2 will be 2 over 4 times 2, which will be 8. And then 5/8 minus 2/8 will end up being 3/8. So 5/8 minus 1/4 gives us the answer of 3/8. Okay, now for the 5 1/3 minus 2 3/4. 5 1/3 minus 2 3/4. Now, there is a method of doing this. There's like 2 methods here. I'm going to give you the easier one because the one method that they have was you're going to have to find an LCD. You'll have to do a little regrouping with your whole numbers, convert that to a fraction with the common denominator. However, if I write these as improper fractions, that would be easy to do. And then the final answer will be converted to a mixed number. So here's how I'm going to do 5 1/3 minus 2 3/4. First of all, I'll convert those to mix to an improper fraction. Like 5 1/3 would be this. 3 times 5 will be 15, plus 1 will be 16 over 3. And then 2 3/4, 4 times 2 will be 8, plus 3 will be 11. So I have 11 over 4. And now I need to find the least common denominator for 3 and 4. It'll have to be 12. So now I'm going to have a 12 here and a 12 here. Now, if I want 16/3 to have a common denominator of 12, I need to multiply the numerator and the denominator by 4. Okay, because I have to think of this. 3 goes into 12 4 times. So let's multiply the numerator and the denominator by 4. 16 times 4, that's 64. For 11/4, if I want this 4 to have a denominator of 12, I need to multiply the numerator and the denominator by 3. 11 times 3 will be 33. Now we're going to subtract 33/12 from 64 over 12. Well, 33 from 64 would be 31 over the 12. Now, 31/12 is an improper fraction. I'm going to convert that to a mixed number. So if I divide 12 into 31, that's going to go 2 times, and I'm going to have 7 left over. Now, of course, you can do the long division here. So 31/12 will be 2 7/12. Okay. All right, these next pair of examples show the use of fractions in algebra. One's an addition, the other one is a subtraction problem. So here I got x over 2 plus x over 3. Now here I need an LCD of 2 and 3. It'll have to be 6, because 6 is divisible by 2 and 6 is divisible by 3. In fact, 6 is the smallest multiple that's divisible by those two numbers. So now for the x over 2, if I want that denominator to be 6, I need to multiply the numerator and the denominator by 3. And for the x over 3, if I want that denominator to be 6, I need to multiply the numerator and the denominator by 2. So for this one, x times 3, that will be 3x over 2 times 3, which is 6. plus 2 times x, that's 2x, over 3 times 2, which is 6. Well, my denominators are the same. I can go ahead and add the numerators together. 3x plus 2x will be 5x all over 6. So x over 2 plus x over 3 will be 5x over 6. Now for part B, I got 1 over x minus 1 over 2x. Well, in this case, I need an LCD. Well, I got the 2, I need that. There's an x, but I need the x to be for the highest exponent. I need the highest exponent for x, which is going to be the x squared. So 2x squared will be my LCD for x and 2x squared. Now let's write our equivalent fractions. For 1 over x, if I want that denominator to be a 2x squared, I need to multiply the numerator by 2 and the denominator by 2. That x needs to be x squared, so I need to multiply by x in the numerator and the denominator. So 2x will have to be multiplied in the numerator and the denominator, and then minus 1 over 2x squared. Well, I've already got the LCD of 2x squared. So I'll need to multiply the numerator or the denominator by anything. So here, 1 times 2x will be 2x. Over x squared times 2x will be 2x squared. Minus 1 over 2x squared. The denominators are the same, so I can write the 2x minus 1 on top and 2x squared on the bottom. And that will be the final answer there, 2x minus 1 over 2x squared. Okay. All right, on the next page is just some homework examples that are related to subtracting whole numbers. Well, subtracting rational numbers, I should say. Here we got 7/10 minus 2/5 in part A. And in this case, I need an LCD for 10 and 5. Well, that LCD is going to be 10. Because 10 is the smallest number that's divisible by itself and by 5. Now let's write our equivalent fractions with a denominator of 10. Well, 7/10 does have the denominator of 10 already. But for 2/5, let's bring with a minus. For the 2/5, I need that denominator to be 10. So I need to multiply the numerator and the denominator by 2. So here I got 7/10 minus 2 times 2 will be 4. Over 5 times 2 will be 10. 7/10 minus 4/10 ends up being 3/10. So in this case here, 3/10 is the answer for 7/10 minus 2/5. Now part B, we got 5/14 minus 3 and 5/8. For me, I would go ahead and convert 3 and 5/8 into a improper fraction. So let me bring the 5/14 over, and then minus 8 times the 3 will be 24, plus 5 will be 29 over 8. Now here comes the hard part. I'm going to need an LCD for 14 and 18. In other words, I need the smallest number, the smallest multiple for 14 and 8. Okay, so I want to think about this. It's 56. Now, what you could do there is list the multiples of 14 and the multiples of 8. And you're going to find out that you will get 56 as the smallest multiple for 14 and 8. Now, here's how we write our equivalent fractions. For 5/14, if I want that 14 to be 56, I need to multiply the numerator and the denominator by 4. And then for minus 29 over 8, if that 8 is to become 56, I need to multiply the numerator and the denominator by 7. So now 5 times 4 will be 20 over 14 times 4, which will be 56, minus 29 times 8 is going to be 232 over 8 times 7, which is 56. And now let's subtract 20 minus 232. This will be a negative 212 over 56. And then if I divide 56 into 212, let's see what that's going to look like if I do the long division off to the side. And I know that it will be negative. 56 goes into 212. I'm going to say 3 times. 3 times 56, this will be 168. 168 from 212 will be 44, which is less than 56. So my whole number is going to be 3, and it will be negative 3 over 44, 56. Now that can be reduced. I want you to know that can be reduced in simplest form. By dividing the numerator and the denominator by 4. So I know I got negative 3 over 4 goes into 44 11 times. 4 goes into 56 14 times. So my final answer there will be negative 3 and 11 fourteenths. Or did I do something wrong here? Let me do my correction here. Let's see. 212 divided by 56. Okay, that's negative. That's going to be 3. So 3 times 56. Oh, that should be, yeah, that's 168 minus 212. It is 44 over 56. Okay, I need to make a correction right here. When I did 29 times 7, that should not be 232. That should be 203. So let me correct that. That will pretty much change everything else in this problem. So when I do 20 minus 203, that would be negative 183. So I need to change this to a negative 183 if I can. It's negative 183 over 56. And then everything else is going to change. So here, so here's what's going to happen. If I do 56 into 183, let's see, 56 goes into 183, of course, 3 times. 3 times 56 is 168. 168 from 183 will be 15. So this would be -3 and 15 over 56. Okay. -3 and 15 over 56. Okay. I apologize for that correction. For that. Okay. It was way up here that I made the mistake. Okay. Now let's look at some application problems that are related to rational numbers here. A class consists of 1/2 freshmen, 1/4 sophomores, and 1/8 juniors. The rest are seniors. What fraction of the class is seniors? Okay. So I want to find out what fraction of the class is seniors. So we need to add 1/2, 1/4, and 1/8. Well, the LCD of 2, 4, and 8. Let's use 8. And write equivalent fractions for those. 1/2, I need to multiply the numerator and the denominator by 4. For 1/4, I need to multiply the numerator and the denominator by 2. And I've already got the 8 as the LCD. So 1/2 times 4 over 4 will be 4 over 8. Plus 1/4 times 1/2 will be 1. I'm sorry, this should be 2 over 2. Numerator and the denominator need to be multiplied by 2. So this will be 2 over 8 plus 1 over 8. And that will give us 7 over 8. 4 plus 2 plus 1, that will be 7 over 8. That consists of freshmen, sophomores, and juniors. So now, what fraction of the class is seniors? Well, the whole class consists of all freshmen, sophomores, juniors, and seniors. So that's 1 whole minus 7/8. And how many 8s are there in a whole? It will have to be 8. So it's 8 over 8 minus 7 over 8. So it'll be 1/8. So 1/8 of the class are seniors. 1/8 of the class are seniors. Okay. So in this case, that 1 whole with a denominator of 8 will have to be 8 over 8. Because there are 8 8s in a whole. Okay, let's look at the next example. A clerk sold 3 pieces of one type of ribbon to different customers. One piece was 5 3/8 yards long, another was 3 5/7 yards long, and the third was 19 3/4 yards long. What was the total length of that type of ribbon sold? And in this case here, we're going to have to find the total length. That means we're adding these 3 lengths together. So we're going to be adding 5 3/8 to 3 5/7 to 19 3/4 yards. Now, what I would do is go ahead and convert these to improper fractions here. So if I do 8 times 5, that'd be 40 plus 3 will be 43, and that will be over 8. Plus 7 times 3 will be 21. 21 plus 5 will be 26 over 7. Then 19 3/4 will be 4 times 9. 4 times 19 will be 76. Plus 3 will be 79 over 4. Now we need the LCD of 8, 7, and 4. Well, I know for 8 and 7, it will have to be 56. And 56 is divisible by 4. So let's use 56 as a LCD for those three fractions. And for each one of those, we're going to write the equivalent fraction. So for 43 over 8, if I want that denominator to be 56, I need to multiply the numerator and the denominator by 7. And then for the 26 over 7, if I want that denominator to be 56, I need to multiply the numerator and the denominator by 8. And for 79 over 4, for that denominator to be 56, I need to multiply the numerator and the denominator by 14. Now, 43 times 7 will be 301 over 56. And then 26 times 8 will be 208 over 56. 79 times 14 will be 1,106 over 56. Our denominators are the same, so let's go ahead and add these numerators together. So 301 plus 208 plus 1,106 will give us 1,615 over 56. Now, we're going to need that as a mixed number. So if I divide 56 into 1,615, I know the whole number will be 28. And then if I do 56 times 28, that would be 1,568. Subtract 1,615 from that, you will get 47. And that will be over 56. So as a mixed number, the total length of that type of ribbon sold will be 28 and 47 over 56. Okay, here's another homework example, similar to the one in my math lab. From a 22-foot roll of rubber hose, a person cuts lengths of 7 3/8 feet, 7 1/2 feet, and 3 1/4 feet. How much hose is left on the roll? So we need to add these lengths that were cut and then take that total and subtract it from 22. All right, so let's add 7 3/8 to 7 1/2 plus 3 1/4. And let's find the LCD of 2, 4, and 8. Well, in this case, it's going to have to be 8. Now for the 7 3/8, or let's do this first. Change each one of those to an improper fraction. Probably easier to do it that way. All right, 7 times 8, that's 56, plus 3 is 59 over 8, plus 2 times 7 is 14, plus 1 is 15 over 2, plus 4 times 3 is 12, plus 1 is 13 over 4. Now, least common denominator is 8, so let's write the equivalent fractions. Well, 59 over 8 does have the LCD of 8. But for 15 halves, for that denominator to be 8, I need to multiply both the numerator and the denominator by 4. And then for the 13 over 4, if I want that denominator to be 8, I need to multiply the numerator and the denominator by 2. So next I'm gonna have 59 over 8 plus, let's see, 15 times 4 would be 60 over 8 plus 13 times 2 will be 26 over 4 times 2, which is 8. If I add 59, 60, and 26, I will end up with 145 over 8. And 145 over 8, if I divide 8 into 145, that would be 18, with 1 left over. So it'd be 18 and 1, 8. Okay, that's the sum of those 3 lengths that were cut. Now we want to find out how much is left on the row. So we got to do 22 minus 18 and 1/8. Okay. Now, unfortunately, the way I'm going to have to do this is I know I can't subtract 1/8 from nothing here. So let's do a little regrouping. I'm going to take 1 from the 22, that'll make that 21, and convert that 1 whole. How many 8s are there in 1 whole? 8 over 8. And then we can subtract 18 and 1/8 from that. So 1/8 from 8 over 8, that's 7 8s. And 18 from 21 would be 3. So there are 3 7/8 feet of rubber hose left. Okay. And this is one of those problems where I had to do the regrouping because I didn't have a fraction. All I had was the whole number 22. So take 1 from the 22, you'll get 21. That 1 whole, you'll write that as the same numerator and the same denominator with that common denominator of 8, because 8 8s makes up 1 whole. Okay. Here's another one. One recipe calls for 4 1/2 cups of milk, and a second recipe calls for 4 3/4 cup of milk. If you only have 10 cups of milk, can you make both recipes? And why? Okay. So let's add 4 1/2 to 4 3/4. And that sum has to be less than 10. Okay. Now, what I can do here is just find the LCD of 2 and 4, which is, of course, 4. And write your equivalent fractions. I'm going to bring over the whole number of 4. For that 1/2, if I want the denominator to be 4, I'll multiply the numerator and the denominator by 2. 4 3/4 already has a denominator of 4. So 1/2 times 2 over 2, this will be 2 over 4, plus 4 and 3 over 4. Let's see, add the whole numbers. 4 plus 4, that will be 8. 2/4 and 3/4 will be 5 over 4. Now, that 5 over 4 is an improper fraction. So if I divide 4 into 5, that's going to go 1 time, but I'm going to have 1/4 left over. That 1 whole plus that 8 would be 9. So the total number of cups of milk would be 9 1/4 cups. But here I have 10 cups of milk. So can I make both recipes? The answer is yes. Okay, because the sum of those two is less than 10 cups. Okay. Okay, now we're going to talk about estimation with rational numbers. Many of the estimation and mental math techniques that are used with whole numbers also work with rational numbers. And here, estimation plays an important part or important role in judging the reasonableness of computations, like in this example. A sixth grade class is collecting cans to take to the recycling center. Becky's group bought the following amounts in pounds. About how many pounds does her group have altogether? Here we got 1 1/8, 3 4/10, 5 7/8, and 6 over 10. Here we're going to use front end estimation and then adjust by using 0, 1/2, and 1 as reference points. Okay. All right, on the next page, not on the next page, we'll just do this problem here and try to find out what that answer is going to be using front end estimation. All right, in this case here, I'm going to use the 1, the 3, and the 5, the whole numbers that are in front of the fractions. If I add those, that's going to be 9. All right, now for my fractions, in this case here, 1/8, that's close to 0. So here I'm using 0, 1/2, and 1 as reference points. So 1/8 is going to be close to 0. 4 over 10 is 1 less than 5 over 10, which is actually 1/2. So I have 1/2. And then 7/8 is almost 1. So that'd be plus 1. 6 over 10 is closer to 5 over 10, which is actually, in simplest form, 1/2. So if I add 1/2, 1, and another 1/2, I'll get 2. And then finally, 9 plus 2 equals 11. So the group altogether has approximately 11 pounds. Okay. All right, so now here's a couple of examples here. Let's say I want to estimate each of the following. Like 27 over 13 plus 10 over 9. Well, if I was to convert that to an improper fraction, 27 over 13 would be this. 13 into 27 will go 2 times with 1 left over. So it would be 2 and 1/13 plus. For 10/9, if I divide 9 into 10, that goes 1 time with 1 left over. Well, if I do a little estimation here, 2/13 is going to be approximately 2. 1 and 1/9 would be approximately 1. So here, an estimate would be, like if I do 2 plus 1, that would be 3. So a good estimate for that would be 3. And part B, 3 and 9/10 plus 2 and 7/8 plus 11/12. Let's see, 3 and 9/10 is close to 4, so let's use 4. 2 and 7/8 is closest to 3. Let's use that. And then 11/12 is almost 1, so it'll be plus 1. 4 plus 3 plus 1 is 8. So that sum would be approximately 8. And here's a homework example of the following ruler containing segments marked M, A, T, and H. Use mental mathematics and estimation to determine which segment contains the fraction 44 over 32. Well, if I do 32 and a 44, that's going to go 1 time. Okay, 1 time. But there's going to be 12 left over. So it'll be 1 and 12 over 32. And by looking at this ruler, 44 over 32 will be in this area right here from 1 to 2, which is the letter M. Okay. So the segment that is labeled M will have the fraction 44 over 32. Okay, so that will complete this video in section 6-2, dealing with addition, subtraction, and estimation of rational numbers. Do feel free to email me if you have any questions about any of the material that's presented in this video, or if you have any questions about the homework in my math lab.